Initially, raw soybeans undergo cleaning to remove impurities such as dirt, stones, or metal fragments. The beans are then conditioned and flaked to increase their surface area, enhancing the efficiency of oil extraction. Flaking is crucial because it breaks down the soybean structure, making the oil more accessible. After flaking, following this preparatory phase, the actual extraction process begins. Modern soybean extraction equipment predominantly uses solvent extraction methods, where a solvent, typically hexane, is applied to the soybean flakes. Hexane effectively dissolves the oil, creating an oil-solvent mixture known as micellar. The micellar is subsequently separated from the defatted soybean meal through distillation processes. After extraction, the crude soybean oil undergoes refining to remove impurities such as phospholipids, free fatty acids, and colorants. This step ensures the final product meets food-grade standards. Refining includes degumming, neutralization, bleaching, and deodorization stages. Efficiency in soybean extraction equipment lies in its ability to optimize these stages while minimizing waste and energy consumption. Continuous technological advancements focus on improving yield, reducing solvent residues, and ensuring environmental sustainability. Thus,